Being a software developer, no doubt you come across people who pitch you ideas all the time, constantly. We all have that friend, maybe friends who come to us and like, hey, I have a new situation, new business idea, I have a new way to make money, except you're gonna do all the job. I'm gonna send you this idea, you're gonna do all the job, send it back to me, and we share the revenue. Being an artist is no different. I come across this on Twitter the other day. It says, bro, I just need to know what exactly you want me to make. All you're doing is throwing some vague descriptors. Do you have a creative brief or write up for what you need? And then our crypto bro here, our NFT bro here goes, what do you think is best? I just need vibes. What do you mean, what do I think is best? I don't even know what this is for. I need look and feel, and then we'll develop further with that emoji that further. What do you offer? Okay, then show me the vibe. What does that mean? The vibe of what? There may be language difference. I'm sorry, I just need to be sexy. Bro, I don't know what you want me to make. If you can do it, it's fine. Just need good vibes. I don't even know if it's serious, but this is the state of the whole NFT, metaverse, crypto, and it's one of the reasons why I'm not more active in this space, in the whole Web3 space, because I feel absolutely creeped out, around that kind of vibe. I don't vibe with that. I don't vibe with this, NFT bros. Here's a shit. Let me share a coin. Let me tell you about the next big thing, the NFT, hype it, and here's some JPEGs, here's some PNG. Go around, sell it for what 20 million, 30 million. I don't know. I don't vibe with that. It's just not my vibe. So that's the reason why I stay some distance away from all of this, and I just want to look at what's real here, what has real substance, what has real value, and just want to look at that and try to separate the good from the rest of the noise, try to separate the signal from the rest of the noise. Obviously a very personal opinion, it's a very personal take. I may be wrong, and maybe in 10 years time somebody's gonna come and tell me that, hey, you're completely wrong, there is so much value in this, and you missed the boat. Well, that's fine, I accept that, because the way it is right now is just, is this a circle? I look at it and I ask myself, is this a circle that you want to be part of? Can you actually create value? Do you see this circle creating real value and solving real problems for businesses, for people, making people's life better? I don't know. I know that every new technology, there is always going to be this curve, the adoption curve, and right now it's just at a peak hype, overhype, and unless it starts to develop some sort of utility that it could be backed by real substance, then my position on this may change. But as it stands right now, it's just not for me. I'll teach you how to create tools on the blockchain and leverage on this amazing technology, but my personal opinion is I look at all these NFT bros hanging around and stuff like that. I don't know. But anyway, it was funny at first, but then I thought about it for a bit more. I said, what you should do, what's the right thing to do here, is to respond to it and take the offer. Take the offer, deliver the vibes. But you say, how do I deliver the vibes? I don't even know what this guy wants. So what about this? What if I teach you how to create generative art in Python, or maybe in JavaScript, I don't know, in Python, and you're going to generate thousands of images, beautiful images, vibes images, in minutes. And we're going to do that all in Python. I'm not trying to encourage you to go into this NFT space. I'm not trying to give you any kind of advice on whether or not this whole thing I feel is a scam, but I don't know. I mean, it's up to you what you want to do with it. But my purpose is to teach you a set of skills. You can use that set of skills to generate images and provide that as a service. And in this case here, you could give your NFT bro the vibes and images. And if it takes you minutes to generate tons of images, thousands of images, beautiful looking vibes images, then it's probably going to be worth putting up with requests like that, right? So let's get started. Okay, I have my IDE ready to go. We're going to be using this amazing library called Samila, S-A-M-I-L, Samila. I don't know how you pronounce that. Maybe Samila. So in any case, you want to install that, pip install Samila. I'm actually using the 0.6 version, so you want to do it like this. Pip install, let me zoom in a little bit so you can see better. Pip install Samila 0.6 by Mr. Sapan. I apologize if I pronounce his name incorrectly. I'll leave a link in the description as well. You can go and read more about the project. But go ahead and create a new environment if you haven't done that, and proceed to do this pip install. So I'm in my environment and I've done my pip install, so I'm not going to do that. This should also install a number of dependencies, of which there are only 3 of them. So there's matplotlib, goes without saying because you're generating art. And then there's requests, and there is art, ALT. So those are the 3 dependencies. So if you go ahead and just do a pip install Samila 0.6, it's gonna do all of that for you. And because I have that already, I'm not gonna worry about this now. Make sure you have the library installed. But let's go ahead now. I'm just gonna create a new file. So just gonna say explainer.py again. That's what I like to do now. Just call it explainer. And then I'm gonna Control P explainer.py, right? So that will just bring you into that file.
And from here, we're gonna just see a very simple routine. The routine to create generative art is actually really quite simple. It's maybe 4 or 5 lines of code, right? Let's go ahead and bring our library in, and let's say from matplotlib .pyplot import plt, and then from samila import generative image. So that's that. So the first thing is to create an instance of generative image, this class right here. So you can name it anything you want, but you want to keep it simple, you can just call it G. If you want to give it a fancy name, you can. It takes 4 optional parameters, but for now we're just gonna pass in none of that, right? Just say take the default option, and then from here you want to say generate. So what does generate do? Generate also actually takes a few parameters, optional parameters. All of them are optional parameters. This one takes a few. This one takes 4. We're gonna talk about them later once we've done the first round of demo. So 4 optional parameters. This one also has a couple of parameters. They are also optional. We're gonna go into the details of each one of them, so don't worry about that. Okay. So this one also takes 4 optional parameters. This is gonna generate your art using some sort of mathematical functions that we're gonna take a look at later. But once you've generated that, you want to plot them, because if you don't plot them, you're not gonna see it. So let's go ahead and say plot. And once you've done plot, you want to just say show, because if you plot them, it's going to create a plot, but you're not actually using any device to show it. So plot.show starts an event loop. It looks for all the currently active figure objects. So this one, for example, it creates a interactive figure object. That's the matplotlib figure object, and it opens up one or more interactive windows that display your figure or figures. So if you create multiple plot and you say plot.show, then what matplotlib is going to do is it's just going to show all these different windows, each one containing your figure. Alright, so the plot.show command does actually a lot under the hood, as it must interact with your system's interactive graphical backend. But let's save all of this. There's only, say, 4 lines of code, not counting the import statements. If you name it explainer like I did, you want to just say python explainer.py. That's it. And let's run that. It says cannot import name plt, because we make a mistake here. Instead of that, we want to say import matplotlib.pyplot as plt. And now we save that, clear the screen again, and run that again. And you should see a nice plot. So this is what I see on my screen. I don't know what you see, but you'll get a different figure each time. And if you want to, you could save this image. I'll show you how to programmatically write a script that generate 20 of them, 50 of them, and then save them. But for now, if you want to manually save it, there is this save the figure button. I don't know what backend you use. But if during the exercise, if you get an error message, your error message is going to say something like matplotlib is currently using AGG, the egg, which is a non-GUI backend, so it cannot show the figure. If you see something like that, then proceed to install tkinter. So tkinter. This is how it's spelled. So if you see a message that says that matplotlib is currently using AGG, it doesn't have tkinter, you cannot use that as the GUI backend, then just go ahead and install it. For example, on a Linux machine, you could do that by doing sudo apt install python3-tk, right? And if you are on Windows or Mac, just search it up. How do you install tkinter? It should be just 1 line of code. Another option is to do it pip install pyqt5, pip install pyqt5, and this will also work, right? So install any of the matplotlib supported GUI backends, and it should work as well. So either do that, either do the Python, either do the first route or do a pyqt5. Any popular options for matplotlib would work, right? So if you have qt5 egg, gtk egg, qt4 egg, any of these will work. In this case here, if you want to use pyqt5, just go ahead and do that. If you see an error, if you don't see anything, it means that you already have that on the machine, then you don't need to do anything. And just to give you a bit of context, the error appears when you pip install matplotlib and you are trying to display a plot in a GUI window and you do not have a Python module for that GUI display. So just go ahead and do that. Take about 1 or 2 minutes, pause the video and do that. And the reason for that is because the authors of this matplotlib library, they make this matplotlib not depend on any GUI backend, because they know that there are people who want to use matplotlib without using any GUI backend. And so they make it free of this dependency. So you want to go and install your own. Okay, let me go back to my script. Let's try and run this again just to make sure that we see a different image, so that you see what I mean by this. And I'll explain this process a little bit later. I'll explain the process about how you get a random image stuff. Okay, I see another image. Okay, that's cool. That's nice. So can I close it down now? What about customizing generative image? Can you set up some parameters here to change how it looks and stuff? Absolutely. So let's start by customizing the generative image instance with our own formulas, with our own mathematical functions. For this, you need to import a random library because you want to generate some randomness in your image. So what we're going to do is we're going to just say import math and import random, because we need this to sort of create some randomness here. Hopefully it comes across as being very intuitive why you would need the math, because this is generative art and you want some sort of randomizer to give your image that vibes, that flair, right? That vibes pretty much. So we're going to see how many times we get to use the word vibes per 60 minutes. All right. So within generative image itself, you can actually define your own function. So you can have something like function 1, function 2, like this. And you can have function 1, and you can define your own function. But to make it tidy, I'm not going to put it right in here. I'm going to actually create that, and then I'm going to fit that in here. So I'm going to say define function 1, function 1, and I'm going to take x and y. It's a 2D plot, so two-dimensional plot. And we're just going to return x and y. Then here you can just say function 1 equals to f1, or you could just use positional and just say f1. And you can have a second function, so define function 2 and then x and y again, and you want to do something, return something. If we only just return the x times y, it's not going to bring in any randomness at all, so it's not going to give you that flair, it's not going to give you that vibes, so you don't want that. So what we're going to do is we're going to say random uniform. This is actually a pattern that you see, -1, 1, and times some sort of value. Here it could be x, for example, but you also want it to be a little bit more complex than that. So you maybe want to make sure, like, let's say give it to the power of 2, you know, just give it some sort of, you can make it parabolic if you want to, but you want to give some flair. So the random.uniform -1 times 1, when you see a random uniform -1, 1, it's trying to randomly assign a positive or negative sign to a value. So this could take a range. This is a scalar between -1 and 1, right? It could be any value between -1 and 1, and multiplied by x, and that x, let's say it's 4, let's say it's 5. It has the potential of actually switching it from positive to negative. So 4 becomes -4. So it basically just applies a scalar, but it also has the potential of switching it between negative and positive. So it's a pretty common pattern. If you have a bit of a linear algebra background, you probably can visualize what this looks like on a 2D graph. But for now, we're not going to talk about that. I'll show you the article about the mathematical details behind how to, what is it actually doing, and what are the coordinates, and how do you project that coordinates and stuff. But right now, I just want to give you a demo, and then we can move on from here. So I want to maybe just add a bit more complexity. We're going to do the same thing here. This brings in the x component, but I want to do the same thing for the y component. So I'm going to say uniform as well, and I'm going to say -1 to 1. Again, this is going to give you get a random number in the range of -1 and 1. So any random number, and from here, this has the potential again to switch it from positive to negative, negative to positive. And here I want to say times y. This is to the power of 2, so y should also, let's say, just to the power of 2. Just make it simple maybe. So x squared, and x squared, when you x square something, you know this is going to be a positive number. So it's not going to have, this is going to be a non-negative value, right? Non-zero, non-negative value. So here I'm just applying some sort of modifier here to give it a scalar, but also say that, hey, you can switch it to negative. There is a chance of that happening using random.uniform. Same thing here, I'm doing that. I'm saying y squared, and again, there's a chance of it being negative. So if you can try and play around with these functions, some of them looks better than the other, depending on how complex your model. If we want to go really complex, you can bring in like math and math.sine, math.cosine. You can do that as well. So let's go ahead and say return, and I'm going to say random uniform, just the same pattern here, and -1, 1. So you have numbers on both sides of the 0, so positive numbers, negative numbers. All right, and here I just want to do something like math.sine, and I'm going to say x and what plus math.cosine y. So that's my two functions. How do I pass them in? You can either say function 1 equals to f1, function 2 equals to f2, or you can just say f1, f2. So that's what I'm going to do. And I'm going to go ahead and make sure nothing changes down here. And I'm going to save that, run explainer.py. Let's see what happens. Okay, there you go. We have one. Does this give you the vibes already? Does this sound like something you can sell to our NFT bro? I don't know. But there's that. And because this is a random process, you can expect to see different results from mine. And if you want to, I could give you a seed and you can reproduce the one watching in the, that you see in this video. So for example, I could try and take print g.seed. I believe that's that. And let me run that again. Okay, my seed is 394,988. So if you want to, you could just copy this 394,988, and you can take that, copy that, and what you can do is to pass in a seed within this. So you can see seed equals to, and then pass that value in there. Then this will give you some reproducibility. You still need to make sure that you have the same functions up here, and depending on how you project that, I haven't talked about that yet, but if you see, there are a lot of optional parameters here as well. So depending on what kind of projectile you get, you may still not see the exact same graph, but you know at least that the randomizer uses the same, is seeded, it's seeded. We'll talk about that concept a little bit later, right? I know that the whole idea, what is seed doing, you're not sure. Don't worry, I'll get into the details later. For now, I'm just gonna remove that, but I'm gonna keep this print seed in case some of you want to follow that, so I'm gonna leave it there. But what you should do is to actually change this function 1 and function 2 to give you that kind of I try to not to use the word wipe too much, but try to give you the same wipe, right? Give you the kind of wipe. So change this formula to make it a little bit more complex. This formula looks arguably a little bit too simplistic. So we let's say this is x times x squared. This is -1. Okay, let's say we keep this, but maybe on the second one we don't want the random uniform to do the same thing. We want to change things up. Maybe we want to use matplotlib, and you want to have like y squared instead. So you want to take y squared and then you put them into sign, and then you can do an absolute value. You can say math.abs, I think, or just abs, yeah, abs. And you can say y minus x or x minus y. You can try one of them. And F2 as well, you can change things up as well. Instead of trying to do this here, we could say take this, multiply by y to the power of 3, for example. And then you say minus math cos, and here you can put x squared plus 2x. So try and vary up your formula, try and change them out a little bit, and then nothing should change at the bottom. Generative image F1, F2, generate. If you want to have some sort of reproducibility, this is how you do it. You hit seed and you pass in a random number in here. So for example, 188,781, and print the seed. This is just gonna print this exact number, and the rest is the same. Let's just run it now. Python explainer.py. Let's see what we get. Okay, we get a pretty good looking. This one wipes hard, really. This one give you really. This one has all the wipes in there. So let's close that out. So play around with the formula, try and make it a little bit more complex, add a bit more complexity. Instead of x squared, we switch it up to the power of 3 instead of 2. You can also try to customize your plot here. So there's the Judah plot. You can actually specify the color. So for example, if you want to see purple, you can see purple, and you can say background color, and let's make it black because everything looks better in black. And we can also set an alpha, and let's say alpha equals to 0.6, just to make it a little bit transparent, just a little bit there. And let's run that. Wow, I think that looks pretty good. I don't know about you, I like this one. This looks pretty good. This is something that I could print and hang around in my bedroom, or my living hall. I like it. I like it very much. So a lot of what you do here in Judah plot, right? You have the color, the background color, the alpha. A lot of this, what you do with all of these parameters, what they do is that they get passed down into the matplotlib anyway. So this is not even a library. This is not something that Samila is actually handling. What it does is that it just delegate that back to matplotlib. If you have done matplotlib in the past, maybe you spent some time in a data analytics, data science bootcamp or tutorial or anything like that, you have some familiarity with matplotlib. Well, this is exactly the same parameters. They just get passed down into matplotlib, and matplotlib is the one that is rendering that with your background color, with your alpha, with your color and stuff, right? So you have any kind of knowledge about matplotlib, that should carry over to this pretty nicely. What about seed? So let me zoom out a little bit so you can see all of that. Hopefully it's still not too small, but if it is, tell me in the comment section to not do that again, but I hope that this is still fine. So the seed method is used to initialize the random number generator. So this is a seed, right? And this is used to initialize the random number generator, RNG, they call it RNG. And let me give you a bit of background in randomness, where it pertains at least to the field of computational science or engineering domains, right? Or computer science. So in theory, most computers are deterministic machines, which means they cannot by themselves generate truly random numbers without outside help. So for example, for a human, if you want to generate some random numbers, you probably take a dice and you roll a dice and say, oh, what number is that? You can make an argument here that somebody rolling a dice is also technically not generating random number, because if you can replicate to the exact scenario, the exact same you know, your exact same hand movement and wind speed or whatever, you can replicate the same number, and that's an argument. I don't want to get into that, but what you need to know here is that computers itself find that task really, really hard. So computers, being deterministic machines, find it really hard to generate truly random numbers. So how do computers generate random numbers then? So computers generate random numbers by observing some outside data, usually things like your mouse movements or your fan noise. Yes, the computer fan noise, which is not predictable, and creating some data from that, right? Anything that serves as a source of plausible randomness can be used, even the temperature of your machine. So if you have, you know, your machine, depending on what temperature it is at the time you call this function, or at the time you hit enter on a keyboard, that serves as a source of this randomness. And this is actually known as entropy. In practice, many programmers use a form of pseudo randomness. They're numbers generated by using an algorithm, so the results appear random even though they're not truly random. So they're called pseudo random. So pseudo random number generators, they work by performing some sort of operation on a value. It takes a value, it does some sort of operation, and then it outputs some other value. Generally, this value is the previous number generated by the generator. So there is a previous value, that it takes this previous value and then it performs some sort of operation and then it spit out another value. You would think that, okay, now there is a problem then, because the first time you use the generator, there is no previous value. So if there is no previous value, how do you take this as input, generate another random number, right? So when you seed a pseudo random number, it gave its first previous value. So when we do something like seed here, this will act as the previous value. If no seed is provided, then at least on Python, the random number generator will use things like your current system time. That's the default behavior. So the default Python's random module, that's what it's going to do, is to use your current system time, right? If you find it confusing, I'm going to open up Python right here just to show you what I mean. Control L, right, let's clear the screen now. Clear the screen. And let me bring in random, import random, right? And I can maybe print some random number. I can say print random number 1, close bracket, and in here let's just say random integer between 30 to 70. I get 41. Okay, so random number 1 is 41. But what if I try that again? Actually, just put a colon here. I get a different number. What if I try that again? 3, I get a different number. Alright, cool. But notice what's gonna happen if I call random.seed. So if I say random.seed, and let's say we use to this date, so 418, 417, right? So if we do that and we try and print random number 1, okay, 68, cool. Now let's do random seed again, and let's do random number 2, 68. What about 3? 68. So you see what's happening here? Is that you can actually use seed to sort of have this reproducibility, so anyone can replicate that same outcome where a random process is involved. So that's the random.seed. Okay, now if we go back to explainer.py, there's also another concept I want to talk to you about. It's called the projection types. So you can have a different projection type for this random art, right? To show you what I mean, I'm gonna go up here and I'm gonna say from samila import generative image. I'm gonna say also import projection. So bring in projection, and we're gonna start working with projection. There is the generate. Okay, all of this is good. We're gonna keep them. Print seed, we probably don't need that, but I can keep that as well. We're just gonna have some random numbers here, and jitter plot, right? So I can actually specify some projection in here. I can say projection equals to, and I can have some sort of projection here. So the default is to use something called a rectilinear, but you can change this to some other figure. For example, you can change this to be a polar. I can say projection dot polar, and then I can have color equals to purple. Let's change this as well to something goldenrod, maybe orange. Background color is still going to be black because everything looks fantastic in black, and that's the vibe we're going for anyway. So projection equals to projection.color, and this is going to change the projection type. So what are the options you have here? So projection types, you can have the rectilinear. That is the default. If you don't specify anything, that's going to be the projection type that it's going to be using. And then there's polar, and there's Adolf, Hammer, Lambert, Mulvey. Alright, so these are the different options for your projection. You can try and play around with that, change those figures and see how it looks like. I'm going to save that. I'm going to go ahead and run the code now, Python. This looks really, really nice actually. Now this one is something that I'll put in my kitchen. I don't know why, but it looks like a kitchen kind of thing. You put this, hang this around in your kitchen. This doesn't look like something I'll put in my bedroom, but it's probably something I'll put in my kitchen. All right, so let's close that out. And for those of you who is wondering, is this the same thing, is this projection being passed on to matplotlib as well? Is this because the fact that it's actually in the plot level? Is this something that library delegate also to matplotlib? And the answer is yes. So if you are not familiar with that, let me open up matplotlib right now and show you what it says on the website. Okay, I have matplotlib open up. This is matplotlib.org and a stable API, projections API, right? There is this matplotlib.projections. I just do a quick search, maybe search for hammer, for example. You see there's the hammer axis, build an axis and a figure. Let's go all the way up to the top to see what it says here. It says this is a non-separable transforms that map from data space to screen space. So if you're creating some sort of data, you have multiple, let's say X, Y, Z, and you want to project them on some sort of projection, this is the transformation that allows you to map from that original data space to that screen space. And projections are defined as axis subclass, and you can see a lot of them. You can see all the choices in here. So search for polar. There's a lot of content here. There's a huge amount of details in here. You can go and read them up on your own, but I'm just gonna point you to these resources if you want to go and dive deeper into that. But I'm just gonna, this is good enough for me. While we're in the browser, so if we paste this in, while we're in the browser, I want to also quickly go into the package with me and show you where you can find more details, especially this section. I'm also going to put a link here in the description. And if you're keen on the mathematics side of things, you can take a look at this section. Samila is simply a transformation between a square shaped space from the Cartesian coordinate system to any arbitrary coordination like polar coordinate system. So you can click on that link, it goes to the projection tab, and it gives you all of these details. And so this is the example. It takes this and it transforms them into this space, right? So basically just changing the coordinate system. We have a set of points in the first space, and this could be any value from negative infinity to infinity, and same thing for x and y. And then from there, below functions are used for transformation. And for example, this is the function that we were experimenting with, and this is applying the function 1 to x, y, and then this is applying the function 2. So you define the function, you still need to apply them, and this is the application, right? Applying function 1. Function 1 takes two inputs, x and y. So here we're passing in x and y. Function 2 takes two inputs, x and y. So you're also passing that, given x and y, right? And from the original space to the new space, this is the application itself, and this is actually the same as what you see here. So x squared, you see x squared here, and then sine y squared, you see sine y squared here, and plus absolute y minus x, that's that. So if you're familiar with LaTeX, this is exactly the same. You could have written this as well. So it takes that, and then here is the same thing, cosine x squared, cosine x squared, and then 2x, and then y squared, y to the power of 3, y to the power of 3. So it takes the original set of data and it performs this transformation, and you see something good looking. But that's what I want to show you, and let's go back into our Visual Studio Code. In my own experiments, I tend to tweak the start and the range a lot more. So let me zoom out now, and this is the whole file. Hopefully you can still see, right? And we have the generate. So I say there are 4 optional parameters, and you've actually seen one of them already. You've seen the seed already, but you haven't actually seen the start, step. We've seen seed already, but we haven't seen start, step, stop. But these are things that you can tweak to give it a slightly, a slightly different generative art each time. So for example, I could go in here and I could say something like start, and let me put a -3, and let me say step equals to, let me change this to 0.01, and I'm going to show you what was the difference when I change this step to 0.07. So 0.01, they're a lot more density, high density, a little bit closer. The step is a lot more gradual and granular, I guess. But let's try and see this, and it's probably easier to see it on the visual than to explain that in words. So let me run that. Okay, so this is 0.01. Cool. And if I change this to 0.07, 0.09, let's see what happened. You see that there's a lot more sparse. It's a lot more sparse. You barely even see the dots connecting. If I have it somewhere in between, let's say 0.05. Alright, it's not as sparse, but still you can't really, I mean, if you zoom in, you take a really good close look at it, you can see the details, but generally it's not. It's not, I don't know, I like it to be somewhere close to like maybe 0.03 looks okay, or 0.0. 1 is okay. You can change different things here. You can also change the start. You can also, of course, change the different stop as well. Let's run that. Okay, this looks pretty okay. If you want a different color, let's maybe change things up a bit. Aquamarine. Okay, this looks pretty amazing actually. Right. So let's close it out again. Oh, if you want to see more colors, any color that so you can use a RGBA color. You can something like for color. This supports RGB specification, RGBA formats as well. So basically you see colors like 333, 333. You know that works. You have like FA, F1, 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 and then A is the opacity. So RGBA, you can also have that, and then like E something, E6 or something. I don't know, but these are all the formats that you can specify. But if you want to see all of them, let me just go ahead and save this and open up Python again. And I'm gonna try and just say from samila params import valid color. And if I print out valid colors, you can see all the different options in here. So you see that obviously there's the BGR, CMYK, Alice Blue, Aquamarine, Azure. So you can change this to say Azure. Save that. Keep this in a new tab. And run the code. So this is how it looks like. Okay, but you don't actually want to manually save them one by one because that's going to be too much work, right? Why do you learn programming if you're going to end up doing this manual label like an amateur? So we're going to learn how to save all these images programmatically. So we're going to generate them and then save them in a folder. And to do that, you need to swap the plot.show. You don't need to show them anymore. You just need to save them. So you can say g.saveImage, and we can give it an art.png. Here there is an optional parameter you can pass in. There is a save image, but you can also pass in an optional parameter. In this case here, it'll be depth. So the default value will be 1. So this is the image depth. So what is image depth? Image depth is this depth parameter is a multiplier on the DPI. DPI, if you haven't heard of that before, depth. Let me add a comment here. It's a multiplier on the DPI. So this stands for dots per inch. And if you're wondering what it means, or if you can sort of make out the meaning already from how it sounds like to you, so that's what you want to tune if you want higher resolution in your exported image. Dots per inch refers to the number of printed dots contained within 1 inch of an image printed by a printer. So if you want to have you want to have very vivid images, you want to have higher depth, right? Higher depth, and it'll change that. And this one actually also is not something that Samila does. It passes it down to matplotlib anyway. So if you look at the formula in matplotlib, this is how it looks like. It says if you go into the code itself, which I did, you go into the code itself, you have a line here. There's a lot of things that it's doing, but there's one line here that controls the DPI, and it says depth multiply by the figure.dpi. So whatever you pass into depth, it gets delegated down here, right? And in practice, you don't have to worry about all these details. I just look at the code in order to figure out what it's doing and to explain that to you on video, but you don't have to figure out all that. In practice, what you really need to understand is that if you want to have higher resolution, you want to have more depth, then just increase the number here. So for example, you can have 3 or 5 even. Most likely 3, it's good enough. But if you want to, have higher resolution, go ahead, get a 5. So let me just save that now. Show you what I mean by that. So explain.py, run that. Now we get .1.png, but nothing comes out now. And the reason nothing comes out now is because we take away the plot.show and we only have save image. So let's click on that, and that's what it's rendering. And you can change this obviously to 5, save it, run it again, and now you have art1.png, and this is better, higher res. I know you can't tell because probably screen is too small, but if you zoom in, you can see the details, and that's that. So change back to 3. So at this point, you have all these techniques to generate different images. I mean, maybe you want to change away the projection. You can change this as well. You don't want this to be you can change some other projection. You can have like Lambert, try something else. Colors, you want to change that. Let's try and do fire break, for example. Even the start and step, you can change that as well. Here, maybe you can change this to something that, let's say, start.math.py and step 0.01. Let's do it one last round and make sure that this all runs before we start to write our for loop. Okay, done. Click on the art. Okay, this is how it looks like. All right, cool. Now let's go ahead and create a directory so we can store all our art. So let's make directory. Let's say arts, maybe arts. Okay, so mkdir make directory arts. And now add a for loop in here. We said for how many images do you want to create? I'm just gonna go with 10. If you want to have like 20, 50, that's up to you. Just, you know, specify a number. I'm gonna start for I in range 10. So that's gonna go from 0 to 9, right? So image 0, image 1, image 2, all the way to image 9. So how many in total do I have? 10, right? And in here, I want to say start the generative process. So bring this in, and optional parameters. Sure, we bring that in as well. But we don't need to care about the seed anymore. So we don't need the seed. I mean, you can have the seed in the image name itself. When you save the image, you need to give it a name, right? You can use a seed as a name if you want to. But, well, I guess let's just comment that out right now. Then we bring the plot in. Just to change things up, I'm going to give it a Dodger blue color. Black is still going to be black, of course. And if you want to add some consistency in all the different tiny images, you can have a different projection. Just change this and put projection equals to something. So for example, you can say projection equals to projection dot polar. And finally, there's our save image. So bring that in, tab. And you can give it a name here. You don't want to call it art1.png anymore, because then all of them will just overwrite the same art1.png. So instead of 10 images, you're going to get one image called art1.png. It's just going to be the last image that it generates, because they keep overwriting each other. So you want to change this and be smart about that. You created a directory called arts, so you want to put them in arts. And here you want to have this, maybe something like underscore. And this is the number itself, so you can have I. So this will become, the first image will become art underscore 0.png. You can also, because this is a polar, I can just add polar instead of art. Then I have polar 0, polar 1, and then I can change the projection to be something else, right? If the projection is hammer, I'm just gonna name it hammer, for example. There's also something you can do is to save the data of that image. The data will be in JSON format, and you can save the data, and I can show you how it looks like. So you can go ahead and optionally, this is optional if you want to, you can say optionally save the data of the image data, and this one you can save in data, and you can also do the same thing. So in this case here, it's probably better off to just have all of this out parameterized. Like this. Like this. But if you don't care about that, then, you know, just delete that. Instead of 10, I'm just gonna save you some time, and I'm just gonna say 5, because otherwise we're gonna have to wait for a while. And we're gonna go ahead and do our explain.py, run that. And now if you look at the odds, you should start to see that things are being generated. Polar underscore 0.png, that's done. And then that's the JSON. Oh, we forgot about the arts. Yeah, this now saved into the same folder, but I guess that's fine. You just, you know, if you want to just change this into something like data, and then you know, data or whatever, we didn't do that already, so that's a little bit too late now. It's really running the process. But there's polar.0.png, let's take a look. Polar1.png, let's take a look. Polar2.png, Polar3.png, Polar4.png, and done. So I've done only 5 rounds of that. If you want to make sure that there is a little bit more difference between the different images that it's generating, then you can also change the parameters here. You can say instead of start equals to 2, you can have something like start equals to I, do a floor division of 2. So what you're doing here is that I, that's this, take a floor division of 2, and from there progressively increment this based on what rounds of iteration would that be. That's the I here. Alpha is also something you can change if you want to. You can have something like 1 minus, and you can have something like take the I as well, and you can say divided by 30. 10, whatever. So those are things you can try and tinker around and play around with. But if I look at my images and I look at my JSON, this is my JSON, I have data. This is what is required to generate that. So Visual Studio Code is complaining that the JSON file is really huge, so I don't really care for that. In fact, I'm gonna remove all of them after this demo. But they look absolutely amazing, and you better trust that I'm bringing up my NFT bro already to sell the whole collection. I don't know, just for giggles. And I'll name the collection Wipes. I'm gonna call this Wipes. And I'm gonna send this to him. Maybe call this the wipes collection. So time to call it a day. I need to ring up my NFT bro and sell the whole collection, my wipes collection. I hope you enjoyed this episode. I hope I gave you good vibes. I hope you make a lot of money off NFT sales on OpenSea. The NFT bro market is large enough that every aspiring digital artist should find their own NFT bro and sell their own collection of wipes. Know anyone that could use some good vibes? Share this video to them. Alright, subscribe for good karma. May you luck out and find your own NFT bro. See you in the next video.